Understanding map and set in Dart. In Dart, collections like map and set provide ways to organize and manipulate data. While a list stores ordered collections of items, map and set offers unique functionality. For example, a map is a collection of key value pair, while set is an unordered collection of unique items. Let's dive deeper into these two essential collection types in Dart. Dart map. A map is an object that associates keys to value. Each key must be unique, but value can be duplicated. Let's look at an example. To write a map, the first thing is that we have the keyword map, and then we can have a name for our variable. And in map, we make use of curly bracket, unlike list that will make use of square bracket. So we have something like this. And then this takes key and value. So just like in your dictionary, you have a word and a meaning that is assigned to it. For example, we can look at hospital. Hospital is where sick people are being treated. So hospital is the key. The value is the meaning where sick people are being treated. So also in map, we have something that we'll call the key. For example, let's look at this. We have this is going to be our key. And then we can have a value assigned to it. So for this, I'm going to add 25. So this is the key. This is the value. Just like I said, the dictionary, you have a word and you have a meaning that is assigned to that word. After each key and value, you add comma, and then you move to the next one. We have Bob. And then for Bob, this is the value. And then we can have Charlie. And at the end of our map, we add semicolon. And this is how we define a map in Dart, the key and the value. Now you can see that we have dynamic here. This simply means that our key is of dynamic type and our value is of dynamic type. That allows us to infer type when we are working with map. So if I come here now, I can say I want on my key to just be dynamic. For my value, I want it to be integer. And like this, all my keys can be dynamic. I can make use of anything for my key. So I can come here, I can say 23, and then I can come here and give this 27. And then I won't get an error because, let me add comma here. And then I won't get an error because I've made all my keys to be dynamic, but my values must be integer. So but if I should come here and I say, let me change 27 to John, you can see I'm getting an error. But over on this now, you see that element type strings cannot be assigned to the map value of type integer. So let's remove this. And to access all the values in our map, you can simply come here and then we can print the H. And let's run this. And then you can see on our debug console, we have our map printed out. Alice 25, Bob 30, Charlie 28. Let's see how we can add an entry to our map. So we have 3 entries in our map. To add another entry, we simply come here and then we can say H. Making use of the square bracket, we write the new entries key. So let's say the new entries key is going to be John. And then we make use of the assign operator and then we'll give it its own value. So I can say 28 and let me add semicolon here. So if I run this again, you can see on my map, I have Alice 25, Bob 30, Charlie 28, and John 28. So that's how you add a new entry into your map. We call each key and value an entry. So to add a new entry, you simply make use of the variable name of your map and then square bracket. In the square bracket, you have your key in the square bracket, and then you make use of the assign operator and you assign whatever value. And then the next thing is, how do we update an entry in map? To update an entry in map, simply come here and then you can say H again. Make use of square bracket. And then let's update Alice H and say Alice, and then you can assign a new H of 26. And if I run this now, you get to see that Alice is now 26. So to update an entry, you simply make use of the variable name of the map again, and then the key in a square bracket, and then the assign operator with the new value you want to update it with. Now let's see how we can access a value in a map. To access a value in a map, whatever value you're trying to access, we simply make use of the key of that particular value. So you take the variable name, we have h, and then we can have a square bracket here. And then let's access Charlie's value. We can say Charlie. And then if we run this now, we have 28. Always ensure that the spelling of your key matches the spelling of the key on the map. If I remove I and I run this now, I will get null because there's no child in my map. Understanding this will really help you when you're working with API in Flutter. Now let's see how we can remove an entry on a map. To remove an entry on a map, make use of a map variable name h.remove, and then we'll pass in the key of the particular entry we want to remove. So this takes dot, and if we should print h again now, you can see we have just Alice and Charlie on our map. Now let's see how we can print out or how we can access all the key on our map, and also how we can access all the values on our map. In order to access all the keys on the map, we simply let's use our print method, and then we can say h dot. When we press dot, we have access to all the keys, and then we can run this. If we run this, we have all our keys printed out on our debug console. If we want to print out all our values, we can just say dot values, and then if we run this, you can see we have all our values printed out on the debug console. And also you can say dot entries, and then you can see we have each map entry printed out on our debug console. Also, when I make use of the dots, I have access to different methods which I can perform on my map. So we have access to is empty, it checks whether our map has data or not. It's not empty. We have access to the length. We can cast. We have contain key, map, remove, to string, update, and the likes. So you can play around with some of these methods to see how they work. Now let's talk about final and constant in map. In that, I can add final and constant to my map in order to make it a final variable, meaning that I cannot change the value of my map. So if I come here now and I say, and I come here and I add final to this, I say let's come down here and say h equals to, you can see I'm getting an error saying final variable age can only be set once. But just like in list, we can modify the values of our list, we can also do the same when it's a final. So I can come here and I can pick a particular entry that I want to modify. So let's say Alice. I can still change the age of Alice from 25 to 26. And if I should print out my new age now, you get to see that Alice is now 26. Let's run this. And then you can see Alice is 26. But in the case of constant, just like in map, we can't do that. If I run this now, I'm going to get a runtime error. You can see I have error say cannot modify or modifiable map. So final in map, content can be modified, but the reference cannot change, while constant in map is completely immutable. Lastly, before I end a discussion on map, let me quickly make mention of this concerning inferring of type in map. So I made mention that you can infer the type of data you want your map to take by coming in front of map and then adding the dynamic and integer, just like I did here. You're not limited to dynamic and integer. You can make this O string and then you can make this maybe double. Apart from this, we can also come here. So let's remove this. We can also come in front of our curly bracket here, and we can do the same thing. Let's say we want dynamic here, and then we want integer here, and we'll still get the same result. Let me move this. It's not supposed to be here. Now let's talk about set in that. A set is a collection of unique items. It is useful when you need to ensure no duplicates exist. So unlike map, where you can have duplicates of entries, and in list where you can have duplicates of values, or we call it items, in sets you are only permitted to have unique item. And let's look at how we write set. So we can say set, we can say number, and then to write set we also make use of curly brackets. So we can have something like this, and then this can take 1, 2, 3, 4, and 5. So unlike map that we use key to access our values, in set, in order to access any item on our set, we can make use of the element at. So we can have number dot element at, and then we'll pass the particular index we want to access. So let's pass index 0, and let's print this out. So you can see we have 1 at index 0, and then for index 2, let's run it. You can see we have 3, and that's how you access items on your set. Set will always have a unique item. So if I come here now and I say, let me add 4 again, I'm getting a yellow line under it saying that 2 elements in a set literal shouldn't be equal. So we can't make use of 2 elements in a set. So we have to remove this, and then let's print this out. Let's run this. And now you can see we have our 1, 2, 3, 4, 5. Now let's see how we can add a new item to our set. To do so, we can come here and we can say numbers dot add, and then we can pass in whatever value you want to add. Let's say 7, and let's run this. And now you can see we have 1, 2, 3, 4, 5, 7. Also, we can remove an item from our set. To do so, we simply make use of remove, and then let's remove 3, and let's run this. And now you can see we have 1, 2, 4, 5. In set, we can check for members. What do I mean by this? We can check if there's a particular item on our set. To do that, we can make use of dot contents, and then we'll pass in the value we want to check for. So let's check for 2, and also let's just duplicate this, and let's check for 5 also. Let's remove our print statements from here. Sorry, and let's come back here. And let's run this. And now you can see we have 2 true, meaning that we have both 2 and 5 here. Let's make use of 7 here. And let's run this. And now you can see for 2 we have true, and for 7 we have false. Now let's talk about set operations. We can perform different types of operation on our sets, be it union, intersection, or difference. Union simply means the combination of set A and set B together to form one single set. Intersection means the unique item we have on both sets, and difference means the value that we have on the first set that we don't have in the second set. Let's look at some examples. We can have print, and then we can say set A dot union set B, and also can have print set A dot intersection set B, and lastly we can have print set A dot difference set B. And yeah, let's run this. So for the first print statements, we have set A union set B, and then we have 1, 2, 3, 4, 5. Now remember our rule in set that we must always have a unique value in every set. We can't have duplicate value. So that's why we have just 1, 3 in our result here. And also the second print statement, set A intersection set B, we have just 3. That's the value that is unique to both set A and set B. And for the last one, which is the difference, we have 1 and 2. That's the value we have in set A that we don't have in set B. We don't take into consideration. So we don't take into consideration the items that we have in set B that we don't have in set A. We only take into consideration the items that we have in set A, and then we don't have it in set B. So before I move to the next concept we have in set, I'm making use of the word item and value. Please note that we make use of items when we have things like list and set. But when we have map, we make use of value. Remember, in our map video, we talk about key and value. When we have an object like set and list, we make use of item. So list of items, set of items. Each list have an item in it, and each set also have an item in it. But when it comes to value, in map, we talk about key and value. Please, let's take note of this. So if you see any way I mistakenly use value when I'm talking about set or list, just note that it's an item. And in map, item is often referred to as the map entry. Also, if you check my tutorial on map, I make mention of entry. So in map, those entries in our map, we call them item because they are being separated by comma, while value is the second part of each entry. And now let's talk about inferring data types before we end today's tutorial. Now let's talk about inferring data types. That type inference make it easy to work with map and set without explicitly specifying types. For example, we can make use of var here, and then we add our variable h, and then we have Alice, which is the key, and then 25, which is the value, Bob, which is the key, and 30, which is the value. By doing this, that itself will infer the data type for our map. So you can see that's infer it as map of type strings and integer. Also for set, when we make use of var keyword like this, that itself will infer the data type for the set. So you can see we have set and it's of type integer. And then when we run this now, you can see, let's run this. Let's see. Oh yeah. So when we use the runtime type method, you can see we have map of type string and integer, set of type int. So that's how we can make use of var with our map or set. That map and set are versatile and efficient data structures for managing collections of data. By understanding their unique features, you can harness their power to build dynamic and efficient data applications. Experiment with these examples to deepen your knowledge and see how they fit into your projects. If you enjoyed this tutorial, don't forget to subscribe, like, and share. See you in the next video. Thank you.